In section 3, now what we're going to do is we're going to start putting a lot of this stuff all together. And then now we're focusing on solving multi-step equations. So we're going to put everything together kind of that we've been working with in terms of the multiplicative property, the property of equality, the addition, subtraction properties of equality, division property of equality, and then also distributing. So we're going to throw all that stuff together basically. So the objective of this section, we're going to focus on solving multi-step equations in one variable. So we're only going to have the one variable still. So we're not introducing a second variable yet. So take a look at this introductory problem here. You're buying movie tickets online for a group of your friends. You have to enter the number of tickets you want on the screen shown. You are using a debit card to pay for the tickets, and you have a total of $45 to spend. Now there's some stuff that you can pull out of this problem. So total right there, that's a good one to identify. How many tickets can you buy? Explain your answer. Now this is really nice because we have rates right here. So it's your rates. Remember, rates always directly translate. So this first rate, $9 per number of tickets. So $9 per number of tickets. So right away we can say, all right, this is going to be 9T. And then there's a processing fee of $1 per number of tickets. So $1 per number of tickets. So those two things directly translate. And then there's also a service charge. So no matter what, you're going to have to pay a $5 service charge. So we also need to tack that onto our price. Now, we are going to buy some tickets, and we are going to be charged $1 processing fee, and we have to pay $5. So now what I'm trying to get you to see or trying to get you to understand is that we can start to translate a lot of this stuff. So $9 per ticket and $1 per ticket and a service fee is going to give us a total of $45. And you can see the great big equation that it generated. And now what we're going to have to do is we're going to have to go through the whole process of how do we solve that. So that's what we're focusing on in this section is how do we solve something that looks kind of like this. So in this lesson, you will learn to write and solve multi-step equations. So the essential understanding to solve multi-step equations, you form a series of simple equivalent equations. To do this, you use properties of equality, inverse operations, and properties of real numbers. You use the properties until you isolate the variable. So you just keep on using those properties. You keep on using the properties that we talked about, that we went through in chapter 1 until you have the variable isolated. So combining like terms. Anytime you're working on these equations, we can combine like terms to make it a little bit simpler. So if you take a look at this problem right here, the first thing I would do in this problem is combine the 5m and the 2m. And that's because they're like terms and they're on the same side of the equal sign. So since they are like terms and they are on the same side of the equal sign, I would commute them around so that they're right next to each other and then add them together. So when I commute them around and add them together, I am now down here at this step. All right, now I need to isolate the variable, which means I need to take the negative 23, that minus 23, I need to get it to the other side of the equal sign. All right, to get the negative 23 to the other side of the equal sign, I would do the opposite operation, which means I would add the 23. So add 23 to both sides. And when you add 23 to both sides, you end up right here. And so that means now your last step, the opposite operation, I would divide both sides by 7. So when I divide both sides by 7, I get my final answer, m equal to 4. And then we can double check that. Does m equal 4? Well, let's plug it back in. 5 times 4 is 20. 20 minus 23 is negative 3. Negative 3 plus 2 times 4 is 8. Negative 3 plus 8 gives me 5. 5 is equal to 5. So it does check out. It makes a true statement. So if I was going to go through these up here, the first thing I would do is combine my like terms, 11m and negative 6m. 11m and negative 6m, I would commute them around so I can combine them. And when I combine them together, I get 5m minus 8 equal to 22. And then if I'm trying to isolate this m, I would add 8 to both sides. When I add 8 to both sides, I now have 5m equal to 30. So I would divide both sides by 5, and I get m equal to 6. For this one over here, commute them around, commute your y's together, combine your like terms. That's why I'm commuting them, is to combine them together, because they are like terms. And like terms have the exact same variable. So 5 and negative 2 gives me 3y. And now if I want to isolate the variable, get rid of the 5. And then opposite operations, we would divide by 3, and we get y equal to 3. All right, so concert merchandise. Let's take a look at this word problem. Concert merchandise. Martha takes her niece and nephew to a concert. She buys t-shirts, and we know that's going to be addition then. T-shirts and bumper stickers for them. The bumper stickers cost $1 each. In other words, it is $1 per bumper sticker. Love that stuff. So $1 per bumper sticker. The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers. Another nephew wants 2 shirts, but no bumper stickers. If Martha's total is $67, what is the cost of 1 shirt? Well, let's take a look. So Martha's niece wants 1 shirt, so 1 shirt and 4 bumper stickers. And then the nephew wants 2 shirts and 0 bumper stickers, so I guess I didn't need to put that. Now, this right here represents how much it's going to cost. This right here represents how much it's going to cost. So if I wanted to figure out the total cost, I would have to add all this together. So if I add all this together, it should come out to $67. All right, now the bumper stickers are $1 each. So I know that these bumper stickers right here are $1. So since they are $1, right now what this would simplify down to is 1 shirt plus $4 for the bumper stickers plus 2 shirts plus 0 is going to give us $67. So if we commute this around, combine like terms, we get 3s plus 4 equals 67. So 3s plus 4 equals 67 right here. So now it's just a matter of subtracting the 4 from both sides and then dividing by 3. So if I subtract 4 from both sides, let's see. So we're right here. So now I'm subtracting 4 from both sides, which gives me 3s equal to 63. So I divide both sides by 3 and I get s equal to 21. So in other words, 1 shirt costs $21. So a shirt is 21 bucks. Noah and Kate are shopping for new guitar strings in a music store. Noah buys 2 packs of strings. Kate buys 2 packs of strings and a music book. The book costs 16 bucks. Let's go ahead and put that 16 in there then. Their total cost, so total, in other words, is going to equal 72. So now since Noah bought some stuff and Kate bought some stuff and their total is 72, we can add it all together. When I add it all together, combine my like terms, and now it's a matter of subtracting the 16 from both sides We got rid of that. So now we have 4s equal to 765, 56. We'll divide both sides by 4. So s is equal to 14. So the strings, 2 packs of strings, how much is 1 pack of strings? So the strings, each pack of strings is $14. All right. Now, when they take these problems just up one more notch, you can see that there's parentheses in here. So let me rewrite this. All right. In this problem, we have a bit of a problem, and that's because of those parentheses. So normally what you want to do, the first step you want to do is get rid of the parentheses. To get rid of those parentheses, anytime you want to get rid of parentheses when you're working with equations, you distribute. So whatever is in front of the parentheses, distribute it, even if it is just a negative. So even if it looks like this, whatever is in front of the parentheses, distribute it. So in this case, I would distribute the negative to each of these and get negative x minus 2. All right. In this case down here, though, I'm going to distribute the negative 8 and get negative 16x plus 8, because it would be negative 8 times negative 1. All right, and now we have a basic problem, basic two-step problem. Subtract the 8 from both sides. Remember, we're trying to isolate the variable. And then divide both sides by negative 16. What does that come out to? My goodness. Well, if we simplify that, what can we do here? We can take a 4 out of each and get x equal to, this is negative, so it's going to have to stay negative, 7 over 4. X is equal to negative 7 over 4. All right. And then to introduce the last thing to you, with this last one here, you'll notice all of these division signs, and I usually just refer to them as fractions. So in this problem, there's a lot of fractions here. Anytime you're working with equations and you have a bunch of fractions in them, normally what you want to do is you want to get rid of the fractions. So if I was trying to get rid of the fractions in this problem, what we would want to focus on is we would want to focus on multiplying everything by the common denominator, excuse me. Multiply everything by the common denominator. So take a look at your denominators and figure out what the common denominator is. In this case, your denominators are 4 and 3. So the common denominator of 4 and 3 is the number 12. In other words, 4 and 3 both go into 12. So what we're going to do here is we're going to multiply everything, multiply every term by the number 12. So take 12 times this first term, 12 times the second term, 12 times the third term. 12 times this first term, 12 times 3 is 36, so you get 36x over 4. 12 times x is 12x, so you get 12x over 3. And then 12 times 10 is 120. Now, the nice thing about this is that 36 divided by 4 is 9x. 12 divided by 3 is 4x, and that's equal to 120. So 9x minus 4x gives you 5x. Divide both sides by 5, and you get your answer, x equal to 24. Now they show it a little bit differently, but usually multiplying everything by that common denominator is usually the easiest first step. So get rid of those fractions. So this one, let's see, that's the one that they do in this second method right here. They multiply everything by the common denominator.